Hello, welcome. Let's look at this Waec question for physics 2018. The number one question. The SI unit of sound energy is A. Hertz Hz, B. Candela CD, C. Decibel dB, D. Joules J. So what is the SI unit for sound energy? Now, for us to understand this very well, we need to take note of very important aspect of solving this problem. Now, the SI unit for energy in general is joules. Now, since the SI unit for energy in general is joules, then sound energy is a form of energy. So the SI unit for sound energy is joules, and that makes D the answer. Now, for more clarity, we are going to look at the SI unit for the other quantities that have these other ones. So let's look at Hertz first. Hz is the unit for frequency. CD, also known as candela, is the unit for luminous intensity. In case if you see the question in another form, that's what CD is for. Now, dB, also called decibel, is the unit for relative loudness of sounds. That's what it is for. So some people might want to pick decibels, but it's not actually decibel, because decibel is the unit for relative loudness of sound. But if you talk about sound energy, the unit is joules. So you can see this Hertz is for frequency, candela CD is for luminous intensity, decibel dB is for relative loudness of sound. So take note. So the right answer is joules, which is the unit for energy, because energy is involved, and the type of energy we are looking at is sound energy. Thank you. Now let's look at question number 2 for physics, Waec past question for 2018. The general definition of elastic modulus is A. Stress over strain, B. Strain over stress, C. Stress times strain, D. Square root of stress over strain. So what is the answer to this problem? For us to understand this problem, we need to understand the simple statement of Hooke's law. So we're going to look at Hooke's law, which states that stress is proportional to strain, provided elastic limit is not exceeded. That's the statement of the Hooke's law, that stress, if you want to put it mathematically, you say stress is what? Proportional. Stress is proportional to strain. And once you have such mathematical representation, you can introduce a constant. So introducing the constant of proportionality, very important. If you want to change your proportional sign into equal to sign, you must introduce the constant of proportionality, and this constant for this case is known as Young's modulus of elasticity. That's the name of the constant that we are going to be using in this case. So if you introduce it, you can now say that stress is equal to constant, which is Young's modulus of elasticity, times strain. That's what you have. So making y the subject, you can now have that y, Young's modulus, is equal to cross multiply, so you have stress over strain, and that is the elastic modulus. So the right answer is A, which is what? Stress over strain, and that is the statement of Hooke's law. So in essence, y, which is elastic modulus, is equal to stress over strain. Very important. So you can be using this to solve some problems. And we also know that stress is simply equal to force over area, and we know that strain is equals to the extension all over the original length. So with this problem, with this equation, you can solve a whole lot of problem using the elastic modulus, stress and strain. So this expression is the same thing as saying force over area all over the increase in length, which I will call here extension, all over the original length. So that is the statement of Hooke's law explained more, where the elastic modulus is equal to stress over strain, because both of them are proportional. So that is the answer. Thank you. Yes, let's look at this question number 3 for Waec Physics 2018. The diagram illustrates a simple barometer. Which distance measures the atmosphere pressure? A. PQ, B. QR, C. RS, D. QS. So which of these distances measure the atmospheric pressure? Is it this PQ? Is it QR? Is it RS? Or is it QS? So which of them? For us to understand this much better, I'm gonna make this very diagram again, and it's basically something like this. With inverted tube, then you're gonna have the mercury. This is the mercury, and it's inside this tube up to a limit. So you have the atmospheric pressure acting downward, pushing this mercury. So when it pushes this mercury, it's going to move into this. So here is vacuum, whereas this very height here is the height that is taken, and this height is actually equal to, for normal at sea level, 760 millimeter mercury. Millimeter mercury because we measure in millimeters of this mercury that is inside. So the height from here to here is actually the height of the atmosphere, which is this atmospheric pressure. So when you look at this, you see that here is P, here is Q, here is R, and here is S. So the actual height is QR. That makes B the answer to this problem, because B is where we have QR. So QR is B. That is the answer to this problem, QR. So that is the answer. Thank you. Now let's look at question number 4 for Physics Waec 2018. The property of a body to remain at rest or to continue in a uniform motion in a straight line is called A. Momentum, B. Inertia, C. Impulse, D. Energy. So what is that property of a body that makes it to want to remain in a state of rest if it is resting, or to continue in a uniform motion in a straight line when it's moving? What is that property? We all know that this property is inertia, because that's the definition of inertia. But I will also explain the other options. So let's take the definition of inertia first. Inertia is that very property of a body that makes it to do what? To remain at rest or to continue in a uniform motion in a what? Straight line, rectilinear motion in a straight line. So that is what inertia is. Now let's look at other things like energy. Why did we say the answer is not energy? Energy is simply the what? Ability or capacity to do work. Ability of a body or its capacity to do work, and it's actually force taken through a distance. Now what is impulse? Impulse is the force, the impact of a force at a particular time or for a number of times. That's force times time. That's what impulse is. And momentum, what is the meaning of momentum? Momentum is simply the product of mass times what? Product of mass and velocity. So you see that none of these three is this, but inertia is this, actually the definition of inertia, and that's why inertia is the right option for this problem. Now let's look at question number 5 for Waec Physics 2018. During a training session, two footballers pass a ball repeatedly between each other. The to and fro motion of the ball is not simple harmonic because the I. Acceleration of the ball is not directed towards a fixed point. II restoring force is not directed towards the center. III acceleration of the ball is not directly proportional to the displacement from a fixed point. Which of the statements above are correct? A. 1 and I and I only. B. I and I only. C. I and I only. D. I and I. So what could be the answer to this? Now, for us to understand it, we need to understand what a simple harmonic motion is. What are the examples of simple harmonic motion? From what we learned, we know that a simple pendulum is an example of simple harmonic motion. And we all know what a simple pendulum is. When you have a rope and you tie a load to it, this is the load. So when you plug this load like this, it's going to make this motion. So it will continue to move like this, continue to move, and the acceleration of this ball is directed towards the middle. It's making this motion over a fixed point. Then another form of simple harmonic motion is when you have a helical spring and you attach a load to this helical spring. When you tap this load small, pump, you see this thing will start vibrating. It will start moving from one point to the other. It will start moving like this, and as it's making this motion, the acceleration is also directed towards a fixed point, just like this one is directed towards this fixed point at the middle. Now when you have your guitar, you have the guitar strings that move and are attached to this point. Now when you pluck your guitar palm, it will start vibrating over a fixed point. So all these motions, both that of a simple pendulum, the helical spring, and a plucked guitar string, all of them make what we call a simple harmonic motion. Now, one very important attribute of a simple harmonic motion is that the acceleration of the load or the string in this time is directed towards a fixed point. Very, very important. And another aspect of simple harmonic motion is that the acceleration of the string or the load in this our case is actually proportional to the displacement from the fixed point. So these are the two things that can make something a simple harmonic motion, whether it's proportional or whether here it is proportional to the displacement, or when the acceleration of the ball is not directed towards the center. So for the simple harmonic motion, the acceleration has to be directed. So if you are talking about simple harmonic motion, this knot and this knot here should not be there, but actually these are the things considered. So for us to now say that this very ball that two people are passing, these two footballers, they pass this ball to themselves, you can see it's making a to and fro motion because it will go here and go here, but now it is not directed towards the center, because this person can apply some force that is even bigger than this person. So the rate at which this one is going is not necessarily the rate at which the ball is getting to this other person. So you cannot say that the acceleration of the ball is directed towards a fixed point. It's not, because it's not even a confirmed straight line movement. And you cannot say that the acceleration of the ball is directly proportional to the displacement from a fixed point. There is no considerable fixed point where you can say that the acceleration is proportional to the displacement. It's not possible, because this person can apply a different force when he's kicking the ball, and this person apply a different force. So there is no surety that they apply the same force. So in that case, you cannot have the acceleration to be proportional, neither can you have this. So these two things that makes something a simple harmonic motion, that makes a simple pendulum, a helical spring, and a plug guitar a simple harmonic motion, here they are put not. So in that case, I and I is the correct answer to this problem. So A is the right option. So A is the right option to this. Thank you. Hello, let's look at this question number 11 for Waec Physics 2018. Now we have the question: an object at rest is said to possess A. potential energy, B. kinetic energy, C. chemical energy, D. electrical energy. We all know that whenever a body is at rest, that the type of energy possessed is potential energy. That is body at rest. We all know that. And this is energy due to your position at rest in a particular place. Then we also know about kinetic energy, which is energy due to motion, energy of a moving body. Then we know about chemical energy, which is energy in chemical substances. The energy you have in cassava, the energy you have in your food, matter, in form of food or any other thing. That's chemical energy. Then we know about electrical energy, the very refined energy that you can use in your house and everywhere. It's very, very refined. It can easily be transported. This is energy due to electricity and flow of electrons. So those are the various forms of energy. So the one that is for body at rest or due to height displacement from a particular point is what we call potential energy. And that is the answer to this problem. An object at rest is said to possess potential energy. If they say object in motion or object with a moving part traveling from place to place with a speed of, whenever you hear the word speed, moving with a speed, you know it's kinetic energy. Potential energy is energy, chemical energy you see in food, or the basic energy that is in matter due to the bonds in the matter. We call it chemical energy. Electrical energy is energy due to the what? Flow of electrons, or the energy caused by electricity. This electrical energy is highly applicable in so many things. So I'm talking to you now, I'm using electrical energy to power my system and other things. So that is that for this. Thank you. Yes, let's look at this question number 15 for Waec Physics 2018. The ice point on the absolute scale of temperature is A. 0 Kelvin, B. 32 Kelvin, C. 100 Kelvin, D. 273 Kelvin. So what is the ice point? For us to understand this, we need to know about the Kelvin and the Celsius temperature scales. Now in the Celsius, we know that we have the, let's say for water, we have the 100 degrees Celsius for boiling. Then we have the ice point, 0 degrees. Then we also have the absolute zero, which is minus 273. This is for Celsius. So we have the equivalent of all these for Kelvin. Absolute zero here is 0. Then here is 0. Anything you have here is anything here plus 273. So if you say minus 273 plus 273, you have 0. If you say 0 plus 273, you have 273. If you say 100 plus 273, you have 373. So that's the difference between a Kelvin scale and a Celsius scale. Every Kelvin is equal to 273 plus the Celsius. So that's how we got about this, because we added 273 to everything here to get this scale. Now this is the ice point, we know. So the ice point is actually on the Kelvin scale, which is the absolute scale, temperature scale. Always know that whenever you say absolute temperature or absolute temperature scale, we are talking about the Kelvin scale. So what's the equivalent of this ice point in the Kelvin scale? Is going to be 273 Kelvin. So this is in Kelvin and this is in Celsius. So the right answer here is D, which is 273. The ice point is 273. So be very, very careful. You might be tempted to pick 0 Kelvin as the ice point. 0 Kelvin is the absolute zero. That's the absolute zero and not the ice point. Ice point is the point, the ice temperature of ice, which is solid water, and that is in Kelvin it is 273. So take note. And Kelvin is also the what? Absolute scale of temperature. So vapor point or boiling point is this point. So take note of all these. So the right answer is 273 when you're taking it in the absolute scale of temperature, which is the Kelvin scale. You understand? But if you're taking it in the Celsius scale, it will be 0 degrees Celsius. But you can see that everything here is in Kelvin. So that makes the answer to this problem. Thank you. Hello, welcome. Let's look at this question number 16 for Waec Physics 2018. Which of the following factors does not increase the rate of evaporation of water in a lake? A. Increase in the pressure of the atmosphere. B. Rise in temperature. C. Increase in the surface area of the lake. D. Increase in the speed of the wind. Now, for us to have a very good understanding of this, we have a lake, and this lake has water. As we all know, there's water inside. Now there is evaporation from this lake. Now, what are the things that will make there to be more water moving from the surface of this lake into the atmosphere? Number one, you will know that temperature does that. Temperature. If you increase the temperature of the water here, they are going to turn into vapor and they will start moving up. So temperature is very, very important. That's number one. Number two is surface area of this lake. If this lake had more surface, you understand, there will be more water going up. So this will also increase the amount of water going up. Now, number three thing that will make there to be more water going up is the speed of the wind. Speed of the wind. If we have breeze flowing, heavy breeze flowing, what's going to happen? They're going to push some of this water out of the lake surface and into the atmosphere. So breeze will help move as this breeze is flowing in this direction or any other direction. It will be picking out the water from the top of the lake and be going up. So all these three factors will increase the rate of evaporation. So what will not increase the rate of evaporation is this option A, which is increase in pressure of the atmosphere. If there is more pressure in the atmosphere, it will even force water to get back into the stream. So atmospheric pressure, forces of the atmosphere, will only make there to be lesser evaporation. So that is why the right option is A, that the only factor that will not, take note of what is asked here, not increase, the only factor that will not increase the rate of evaporation is increase in the pressure of the atmosphere. Every other thing here will increase the rate of evaporation, which is, as I've already stated, these 3 points will increase the rate. So the only one that will not is increase in pressure of the atmosphere. Thank you. Yes, let's look at this question number 17 for Waec Physics 2018. The bulb of a simple pendulum takes 8.0 seconds to complete 10 oscillations. Determine the frequency of the oscillation of the bulb. A 0.80 Hz, B 1.25 Hz, C 7.50 Hz, D 8.00 Hz. So what is the frequency? Now, for us to understand this very well, we know that frequency by definition is simply the number of oscillations per second. So number of oscillations over time is frequency. So the number of oscillations that is completed in a second, that's what frequency is. Frequency is the number of oscillations per second. So how many oscillations is able to be completed in 1 second? Now if you take this number of oscillations from this is 10, all over time 8. So if you do this, you're going to get 1.25 as the number of oscillation all over 1 second. So if you divide through by 8 here will give you 1, so that you can get per second, because it's 1 second. Divide this one by 8, you get 1.25. So you can say that 1.25 oscillations was done in what? 1 second. In 1 second. You understand? whereas you had 10 oscillations done in how many? 8 seconds. So if you can do 10 oscillations in 8 seconds, that means you can do 1.25 in 1 second. And the amount of oscillation that you can do in 1 second is the frequency. So the frequency is 1.25 Hertz. That is why B is the correct answer, because frequency is simply number of oscillations all over time in seconds. So the number of oscillation here is 10 and time is 8 to give us 1.25 Hertz. That is the answer to the problem. Thank you. Hello, welcome. Let's look at this question number 18 for Waec Physics 2018. The diagram above illustrates the mercury in glass thermometer used for determining the temperature of a room. Use the data on it to determine the room temperature. A. 3.3 degrees Celsius, B. 7.0 degrees Celsius, C. 13.0 degrees Celsius, D. 30.0 degrees Celsius. Now this is the diagram we are considering. So considering this very diagram, we can see that what we actually have is this very thermometer. I have this the mercury that is covered in black. Now we have the tube. Now from the indications, we can see that here we have 0 degrees Celsius, and here we have 100 degrees Celsius. Now from this 0 degrees to the point where you have the mercury level, we have 3 cm. Very, very important. 3 cm. Whereas from this point of 0 to the 100 degrees Celsius side, we have 10 cm. So it's telling us that the total length of this mercury tube inside is actually 10 cm, but the level of the mercury here is 3. So what is the room temperature? And we know that the room temperature is around 25 degrees Celsius. That's the standard room temperature. But if we are taking the measurement here, we have 3 cm, but the room temperature is supposed to be 25. So if you take half of here, if you take half of here, then you're gonna have 5 here and 5 here. That's half. Then if you take half of half, so that you can have 25 here, this is where you can have 25 degrees, which is the room temperature. So you can then read this to correlate. So what temperature can it give, given that here this is the reading? So you can see that the very reading here is somewhere above 25, which we should be assuming to be 30 degrees. So from this sketch we can say that the room temperature here is 30 degrees from the reading here. So if you divide this, because this is 100 and this is 0, divide it into 2, you have 50 here. So half of 50 is 25, and the reading here is just above this 25, so it should be around 30, because it cannot be this too small, this too small, this too small. And we all know that room temperature generally is around 25 degrees, so it's very okay to assume 30 than the other ones. So like I said, here is 0 from the diagram, here is 100, divide it into 2, you're having 50, and you have something that is lesser than 50, which we assume to be 30. So 30 degrees is the most likely close temperature, and that is the room temperature. Thank you. Yes, let's look at this question number 19 for Waec Physics 2018. Frequency is measured in A. meter per second, B. second, D. hertz, C. hertz, D. farad. So what is the unit for measurement of frequency? We know that number 1, meter per second is for velocity. That's the unit for velocity. Seconds is the unit for time. Hertz is the unit for frequency, and farad is the unit for capacitance. So these are the various units for these various quantities in physics. So whenever you hear meter per second, is simply the unit for velocity or speed. Whenever you hear times in seconds, is unit for time and period as well. Whenever you hear frequency, it is the unit for, or the unit is hertz. That is what you use as the unit for frequency. Farad is for capacitance of a capacitor. So the right answer is C, hertz. Hertz is what frequency is measured in. Hertz is what, that is the unit of frequency. Thank you. Yes, let's look at this question number 20 for Waec Physics 2018. Which of the following electromagnetic waves is most energetic? A. radio waves, B. X-ray, C. gamma rays, D. ultraviolet rays. Now if you look at the scale for frequency or any other thing, you're going to find out that on one side you have the radio waves, and on the other extreme you have the gamma rays. So in terms of wavelength, this one has the highest wavelength. But in terms of frequency, This one has the highest frequency, gamma ray has, and the one with the highest frequency also has the highest energy. So you can check the properties of the electromagnetic waves in terms of their wavelength, energy, and frequency. So these are the two in the two extremes. So it can either be gamma rays or radio waves. But from what I just showed now, the one with the highest frequency, which is gamma rays, very energetic. It can move. So the answer to this is gamma rays. So you have radio waves. After radio wave, you have what we call microwave. After microwave, then you have other forms of waves like the infrared, the visible light, the ultraviolet, the X-ray, and other ones. So the answer is gamma rays. Yes, let's look at this question number 46 for Waec Physics 2018. Which of the following particles may be emitted in a process of natural radioactivity? A. Alpha particles and beta particles. B. Alpha particles and X-rays. C. Beta particles and S-rays. D. X-rays and gamma rays actually and X-rays. So now, whenever there is natural radioactivity, the particles that are emitted are alpha particles, beta particles, and gamma rays. Now, natural radioactivity is what happens in our daily life, like when you have, mostly it happens in rocks. And this actually causes uranium to be disintegrated into radon, emitting things like the alpha particle, beta particle, and the gamma rays. Now, the alpha particle and the beta particles are trapped inside the rock, whereas the gamma ray escapes. It's very light. So that's what actually happened. So from this option, you can see that the option that has the alpha and beta particle is the A option, alpha particles and beta particles. So there's nothing like X-ray here. So this makes this invalid. X-ray makes this one invalid, and as well here. So this is gamma rays. Gamma rays is also emitted in natural radiation, but it escapes. But the alpha and beta particles are retained or are trapped in the rocks. So natural radiation happens in our, you see there is always radiation bombarding from the cosmic space, bombarding us here on Earth, but we witness it mostly in rocks, and it actually involved the radioactive decay of this radioactive element of uranium to get radon, thereby emitting particles like alpha particle, beta particles, which are trapped in the rocks, and gamma rays, which escape. So the answer is A, alpha particles and beta particles. So take note, this specific concentration on natural radioactivity. Look at question number 48 for Waec Physics 2018. Which of the following radiations has the longest wavelength? A. Gamma ray. B. Radio wave. C. Infrared ray. D. X-ray. So how do we go about solving this very problem? Now, when you check out the electromagnetic spectrum, you're going to find out that if you check according to wavelengths, you're going to find out that the one with the longest wavelength is radio waves, followed by microwaves, followed by infrared, followed by the visible light, followed by ultraviolet, followed by X-ray, then finally gamma ray. So that's how it is. So we have wavelengths of up to 10 to power 4 here, 10 to power 4 to 10 to power 2, whereas in gamma ray we have wavelengths of up to 10 to power 12, actually between 10 to power minus 11 to 10 to power minus 12. So we have the highest or longest wavelength here, radio waves. So radio waves is the one with the longest wavelength, and the one with the shortest wavelength is gamma rays. So from that, you can easily say that the answer here is B, radio waves. So radio wave has the longest wavelength if you check according to wavelength. Wavelength is not the only parameter that you use in checking the quality of the radiation. So we have wavelength, we have frequency, and we have the wave energy, the energy of the wave. So you can use any of these, but considering wavelength, this is how they are arranged. After radio waves, you have microwaves, you have infrared, you have visible light, you have ultraviolet, you have X-rays, then you have the gamma ray. So radio wave is the radiation with the longest wavelength. Thank you. Yes, let's look at this problem. Question 49 for Waec 2018 physics. Which of the following fields are radioisotopes not used? In which of the following fields is radioisotopes not used? Now, if you check out the uses of radioisotopes or radioisotopy, you find out that they can be used in medicine. Very important. They can be used in oil industry for oil exploration. They can also be used in agriculture. Very important. So you can use radioisotopes in studies in all these fields. But the last option, weather forecast, there is no such in our books from what we've read so far under radioisotopy and its application. So it's not actually used in weather forecast. It can be used in medicine, can be used in oil industry, can be used in the agriculture, but not this. So weather forecast is actually the field where you don't use radioisotopes. Hello, welcome. Let's look at this Waec physics for 2018 question 50. A nuclei is represented by B 7032. Determine its neutron proton ratio. This is ratio, neutron proton ratio. Now, given that we have 70 B32, it means that this is the atomic number, whereas this 70 is the mass number. So 32 is the atomic number and 70 is the mass number. But we know that the number of proton plus the number of neutron is equal to the mass number, whereas the number of proton alone is the what? Atomic number. So now, what is the mass of proton alone? Is 32. 32 is the atomic number. Now, whereas the mass number, which is proton and neutron, is what? 70. So to get the number of neutron, we have to do 32 minus 70. So what would that give us? We have 0 here, and we have 6 minus 3. We have 6 minus, we have 8 here. That is 10 minus 2, 8. Then we have 3 here, 38. So number of neutron is 38. So we now have, and we are asked to find the neutron proton ratio. So if neutron is 38 and proton, which is atomic number, we already know is 32, is 32. So neutron is 38, proton is 32. So what is the ratio? So to get the ratio, we'll divide through by the smallest number. So if you divide this by 32 and divide this by 32, so when you divide this one, you're going to get 1. So what will you get when you divide 38 by 32? 38 divided by 32 will give us 1.187. Your 1.1875. So approximately 1.2 is to 1. So what we get is what? 1.2 is to 1. So 1.2 is the ratio, and that makes C the answer to this problem. So C is the answer because it's 1.2 is to 1, and that is the answer. Oh no.
Thank God. Well done. How is it? Progress go from that day.
Yeah. Chika, what happened?
Hello, sir.
So what happened?
Sir, nothing happened.
Huh?
Nothing happened.
Okay, so let's quickly start. Let's tidy up the 2018 physics that we could not do then. So we'll try as much as we can today. And during the weekend, I will sort out the remaining ones so that by Monday we can be able to finish it up. Are you okay with that?
Yes, sir.
Can you see my screen?
Yes, I can see it.
Okay, so let's look at question number 6. Question number 6
So
is part of the
it.
ones we couldn't do that day. Okay, a dam is able to hold a large quantity of water because its wall is A, thickest at the top, B, thickest at the middle, C, thickest at the bottom, D, of the same thickness. So the answer is thickest at the bottom. And this is because water pressure increases proportionally with depth. So the more the depth, the more the pressure. So in order for the dam to be able to hold water of higher pressure at the maximum depth, the thickness there has to be big. Now, if you check the past question, you see that they picked some of them.
So why is it not throughout?
Said what?
Why is it not thickness throughout?
Yeah, I said if you check the past question, you see thickness throughout. So why is not thickness throughout is that because you need the pressure to take care of the maximum, you need the thickness to take care of the maximum pressure. Now, if you make it to be of the same thickness throughout, so that area of maximum pressure, the dam would not be able to hold it. But if you make the whole of the dam to be, all of them to be very thick, then you'll be wasting a lot of materials. You understand? So the optimum design will be for the thickness to be maximum at the bottom.
Okay, sir.
Is that okay with you?
Yes, sir.
Okay, so let's move to question number 7. A body of mass M moving round a circle of radius r with a uniform speed of v experiences a centripetal force F. So the question says,
So what did you say?
body of mass M moving around a circle of radius r with a uniform velocity v, speed v, experiences a centripetal force F. The work done by the centripetal force on it is FV. Zero, isn't it?
Yeah.
Okay, so it's zero because centripetal force is always towards the center of the circular path and is responsible to restrict the particle to move in a circle and not responsible for the displacement of the particle. So the work done is always zero. So let's look at question number 8. A block is acted upon by two horizontal forces as illustrated in the diagram above. The block accelerates at 1.5 meter per second square. Calculate the mass of the block. You can see that this force taking it this side is 10 Newton. Then another force is taking it back, which could be this force taking it back. What kind of force could it be? Check out.
Frictional force.
Frictional force, good. And I told you that whenever two forces like that are acting, then you need to get the resultant force, isn't it?
Yeah.
And the resultant becomes the main force minus the frictional force, which is 9, isn't it?
Yes, sir.
Good, and we all know that F is equal to MA. So we simply make M the subject of the formula. So F here is 9 all over A, 1.5. 9 divided by 1.5 is 6. That makes option A the answer. Are we clear on that?
Yes, sir.
Okay, so let's move on.
Okay.
So I may have to send you this, Abby. Would you need it?
So I'm writing it as you're saying it.
You're writing it. Perfect, perfect, perfect. Okay. So let's look at question number 9. Good. Which of the following quantities are dimensionally independent? That means they don't need other quantities to define their dimension. Number 1, dielectric constant. Number 2, momentum. Number 3, efficiency. And number 4, refractive index. So you have option A, 1 and 2, B, 2, 3, and 4, C, 1, 2, 3, and 4, D, 1, 3, 4. Now the answer is 1, 3, and 4, simply because of momentum. Momentum depends on mass and velocity. And you know that mass has the dimension of AV, isn't it?
Yes, sir.
Mass has the dimension of...
I'm not seeing it on the screen.
Huh?
I'm not seeing it on the screen. They're working.
Sorry. I didn't share it. Let me share it. Let me quickly share it. Let me know once you can see the new screen.
So I can see it now.
Okay, which of the following quantities are dimensionally independent? I, dielectric constant. I, momentum. I, efficiency. IV, refractive index. And the options are A, I and II. B, I, and IV. C, I don't know whether it's I that you call it. You can also call it 1. You know it's Roman numeral. I, and IV. Then D, I, and IV. That's 1, 3, and 4. Okay. So the answer is D, simply because it's only D that does not have momentum. Momentum cannot be dimensionally independent because momentum is simply equal to MV, which are derived dimensions. M is for mass, V is for, what's the dimensional representation of velocity? Huh? Chika, what's the dimensional representation of velocity? L over T, distance over time. L for length, all over
It's a
T.
dimension.
Good. So MV, momentum is not dimensionally independent. Another one.
Speed.
Yes, you have a question?
So what did you say?
You have a question? I was asking you what the dimensional representation of. Huh? Said what?
Of.
I cannot hear you.
So I cannot hear. Hello. Hello, sir. Yes, sir, we can move on.
Number 10, a body is projected with an initial velocity u at an angle of theta to the horizontal. If arrow max is the maximum range of the projectile, what does the relation u squared over arrow max represent? A, the vertical distance covered. B, the acceleration due to gravity. C, the horizontal distance covered. D, the acceleration of the body. Now, arrow max equal to u squared over g is the formula for maximum range. So if you make g the subject, you simply have u squared over arrow max, which is actually what you have here. So that is simply the acceleration of the body. Now, when do you attain such a formula? When do you attain such a formula? You always know that range is equal to u squared sine 2 theta over g. But whenever theta is equal to 45, if you substitute it here, you're going to be having 2 times 45, which is 90, and sine 90 is 1. So that's why you have arrow max equal to u squared over g. So this normally happens when theta is equal to 45, and that is at maximum range. So this expression is simply for acceleration. Are we together? So I'm going to share my other screen so that you see the next one. Okay. Are you seeing number 11? Can you see number 11? Is that what you're seeing? Number 11. Which number are you seeing? Tika, can you see number 11?
Yes, I said I can see.
Number what?
Number 11.
An object at rest is said to possess A, potential energy, B, kinetic energy, C, chemical energy, D, electrical energy.
Potential energy.
That one is pretty simple. Kinetic if they are in motion, chemical.
Potential energy.
Okay, so let's move forward. So let's look at question number 12. According to Newton's law of cooling, the heat energy lost per unit area of a body depends on 1, surface area, 2, nature of surface, 3, temperature of surface, 4, excess temperature over the surrounding. Option A, 1 and 2 only. Option B, 2 and 4 only. Option C, 1, 2 and 3. Option D, 1, 2 and 4. So the right answer is option C, 1, 2 and 3, because the heat energy lost per unit area of a body depends on the surface area, the nature of the surface, and the temperature of the surface. Chika, you still there? Chika, you still there? Chika, you there? Wait for me tomorrow. I'll soon be done. Yeah, how are you? Huh? Okay. Okay. Thank you. Yeah, madam, please come. Still logging on. See, you can talk. Yes. Which one? Which one? Call the boy so that I know what the program you want. Hmm? I know you have not seen it. Yeah, which program do you want?
No, the other one that I've done.
Okay, okay. Basics is 20,000. 4 months. No. Coral draw is good. I want to do Photoshop. Why not? We'll still be doing. We'll do Photoshop. And join us. But it's not normally included in 20,000. But you can do it.
Give me about that.
You don't need textbook when I'm teaching you now. Give you a most of the thing.
Can you finish it within 3 months?
2 months.
2 months.
2 months. In 2 months you will be done. You will then use the rest of the other 2 months to keep practicing if you have time.
I wanted to round up 3 months. Can you possible?
That's what I just said now. That you can
Okay,
finish
2
it.
months. Okay, then another 1 month. Or you can stay for either 1 or 2
Yeah,
months.
I can stay. You can elapse, stay for the 4 months if he has the time. Yeah, but the curriculum will cover it within 2 months. Yeah. If he has time, you can come in, keep practicing, and keep getting better.
That is the amount of. I'm not doing with this. No, but that is very good.
This one I give you. Bring the form down. Yeah, Chika, are you back?
Yes, sir.
What happened?
The network is cutting off.
Yeah, your network was. So let's quickly rush so that we don't like. I have to meet up with something immediately after your class. Huh?
Okay, sir. Number 12.
Yeah, the graph of density against temperature for water is correctly illustrated by.
I think that
Is it the
number
shape?
12 here is not there. Number 12 here is according to Newton's law of cooling, the heat energy loss per unit area of the body depends on the. That is number 12 here.
That's number 12 now. I did it already. Maybe your network wasn't up with them. Can you see my number 12 now?
Yes.
You can see it's the same as what you have there, isn't it?
Yes, sir.
Good. According to Newton's law of cooling, the heat energy lost per unit area of a body depends on the 1, surface area, 2, nature of surface, 3, temperature of surface, 4, excess temperature over the surrounding. And I said that the answer is C. So heat loss is always dependent on surface area, nature of the surface, and temperature of the surface. So with that,
When did
go to
Newton create law of cooling?
Huh?
When did Newton do a law of cooling? What topic did Newton do that law?
What's what?
Topic did Newton do that law? It's only Newton's law of motion and gravitational
Okay, it's
force.
only motion. No. Newton did a lot of work in physics, huh?
Okay, so.
Yeah, it's not only motion that he worked on. Okay, so let's look at 13. The graph of density against temperature for the water is correctly illustrated by, is it the diagram on A, B, C, or D? Now, you remember we did anomalous expansion of water?
Yes, I remember.
You remember? Okay.
Yes, I remember.
So, yeah, the density is supposed to continue to reduce as temperature increases. But for water, from 0 degrees to 4 degrees, it will decrease. It will increase before it starts decreasing. And that makes option C the right answer. If you check your past question, you see they will pick option D. Did you check your past question?
Yes, sir.
Yeah. So the right answer is option C. Eh? So there, from 0 to 4, there is increase. Then furthermore, you have decrease.
Wait, so it must increase before it starts to decrease.
Yes, yes, yes. And that makes C the right answer. And that is simply due to anomalous expansion of water.
Okay.
Are we together?
Yes, sir.
Okay. So I'm going to open the further one so that we'll continue.
Number 14.
Yeah, let's get to 14. So I'm going to share it so that.
Thank you.
Okay. I don't know whether you can see my screen, number 14.
I can see it, sir.
Okay. A football is kicked at an angle of 45 degrees to the horizontal over a defense line up with the velocity of 15 meters per second. Calculate the magnitude of the horizontal velocity of the ball at its highest point. So neglect friction and use G to be 10 meters per second. So option A, 0.0 meter per second, B, 5.6 meter per second, C, 10.6 meter per second, D, 15 meter per second. Okay.
Please, can you scroll down?
Okay. Like this.
Hello?
Should I scroll to the answer? What do you mean by down? I should scroll to the answer. Is that what you mean?
Okay, yeah. No, I couldn't see it well before. It's okay.
Okay, okay, okay.
Yes, sir, it's okay. I couldn't see it before.
Okay. So the velocity normally has the vertical and horizontal components. For the vertical, you have y, which is equal to u sine theta, whereas for the horizontal, you have vx, which is equal to u cos theta. Okay, so if you use cos, it's going to be cos 45 times 15. It will give you 10.61 meter per second, and that is the answer. So Chika, you see, if you check through the past questions, they don't solve, they don't show it descriptively the way I'm showing it. So I have to like take the weekend, make sure I sort out the ones that you don't have, so that when we are doing it, you'll be able to understand them. I mean, for the chemistry and the rest of the physics. One question that is on 14. Don't take that.
Sir, sorry.
Yeah, your network is just, I don't know, it's not helping us. Abi?
Sorry, you can continue.
Your network is not behaving fine today, Abi. So do I continue? Should I continue?
So what did you say? Yes, sir, you can continue.
Okay. So let's get to 21. I think 21 is the next one. Is it 21? Tika, can you see question number 21 on your screen? Can you see 21 on your screen? Yeah, what's up? Huh? It's up. I've sent it since now. Hello? Yeah, good evening. No, I'm having a Zoom class. I'm teaching now. I'm talking. Sorry. Sorry, oh, I've sent it. Check.
Hello, sir.
Tika, what's up?
So I'm not going again. Let me just connect to the Wi-Fi. It's because I'm connecting to the hot one. As calls are coming, it's disturbing it. Ah,
So what do we do now?
Sir, did you hear? I said I want to connect to the Wi-Fi now.
Oh, yeah,
So
connect
it
to the Wi-Fi.
doesn't disturb again.
Connect now. Let's go on so that. Have you connected the Wi-Fi? Sorry. Tika, have you connected to the Wi-Fi?
I'm connecting to it now.
Can you see number 21 as your own screen? Can you?
I'm connecting now.
Oh, yeah. Can you see number 21 as your own screen?
Yes, I can see it now.
Okay, so do I continue?
Yes, you can continue now.
Okay, rainbow formation is a natural phenomenon illustrating that white light A splits into three components after rainfall. B is dispersed by a glass prism. C splits into its constituent colors before rainfall. D is dispersed into its constituent colors by raindrops. So the answer is simply D, because rainbow is simply the dispersion of white light into its constituent colors by raindrops. Now let's head to number 22. Let's head to number 22. And it simply says the lens illustrated by the diagram above can best be described as A, converging meniscus, B, plano-convex, C, diverging meniscus, D, biconvex. So the answer is plano-convex because we simply know the different lenses that we have. We have this is the shape for
So I'm
biconvex.
always mixing the diagram.
Okay, that's why I drew out all of them for you so that you'll be sure of the one you're picking. Can you see all of their diagram?
Yes, I can see it.
Okay, so this is biconvex because you have convex, convex. This is plano-convex. These are concavo, convex. And this is biconcave. These are plano-concave. And this is convexo, concave. So those are the various, in case if you see any of them, you should be able to pick out the right answer.
And concave pencil, yes.
Yeah.
Is it like examples under diverging and convex, or these a different one?
No, these are just types of lens that you can have.
Oh. Okay, sir. Come in.
So let's move forward, isn't it?
Sir, hold on. Sir, please hold on.
Okay, I should hold on, okay?
Yes. So you can change them.
I can change now, bro.
Yes.
If you can see my screen with question number 23, let me know.
Yes, I can see it.
Okay. Two plane mirrors are inclined to each other such that an object placed between them has 11 images. Determine the number of the angle of inclination. Is it A, 30 degrees, B, 45 degrees, C, 60 degrees, D, 90 degrees? So the solution there is number of images formed is equal to 360 over theta minus 1.
Yes.
Okay, so if you make theta the subject of the formula, you're going to have 1 going over to the other side to become 11 plus 1, making it 2. So make theta the subject, cross multiply, have 12 theta equal to 360. Then keeping theta alone, divide through by 12, you're going to get 30, and that makes option A the answer. Is that clear?
Yes, sir, it is.
Okay, so let's move forward. So let's look at number 24. Okay. The pitch of a note is not affected by A, frequency, B, tension in a vibrating string, C, mass of the vibrating string, D, amplitude of the sound wave. Now, the answer is actually the amplitude of the sound wave, because pitch of a note is simply the position of that note on a musical scale. And with the pitch, you can easily differentiate between a high note or a low note. And pitch is dependent actually on the frequency of sound wave. Another quality of sound that we can talk about is loudness or intensity. Loudness or intensity. And loudness or intensity of a sound is dependent on the wavelength, but the pitch is dependent on the frequency of the sound. So if you look at the options, you see that D is the amplitude of sound wave.
So,
The
sir,
other
what
option,
is the amplitude of frequency?
you said?
Okay, so the pitch is affected by everything apart from amplitude.
Yeah, the pitch is actually dependent on frequency. But you know the tension in the vibrating string and the mass contributes to the frequency.
Okay, sir.
You understand? But D is not even the answer, because the amplitude only affects the loudness or intensity of the sound.
So how does the mass contribute to it too?
It will determine, when you're talking about frequency, you're talking about the to and fro motion. How fast is it? You understand? The
Yes,
number
sir.
of seconds that can be covered in a minute or in a second. So if it's having bigger mass, it might not move as fast as you want to get the frequency that you want.
Okay, sir.
Okay, so let's move forward.
Okay, sir. That is number 25. Hello.
Yes, let me know when you can see number
I
25
can
on
see.
your screen. You can see it now, huh? Can you see 25 on your screen?
I can see.
Okay. When two flat plate conductors are arranged in such a way that they possess equal and opposite charges and are separated by a dielectric, they form and what? Option A, electroscope,
I said okay.
B, electrophorus, C, capacitor, D, cell.
Hello. I thought you were telling
So Chika, what do you think is the answer?
Fully electroscope I'm familiar with.
You said?
I said it's only electroscope that I'm familiar with.
Okay,
As
that you're
electroscope.
familiar with. Good. So that's why you can see on the screen that I gave the definition of most of them. Electrophorus is simply a device for transferring and storing charges. And it produces charges by induction, electrostatic induction. This is a diagram of electrophorus having an insulating angle, a metal disc, and an ebonite disc. This is a gold leaf electroscope. And electroscope is an instrument used for dictating and testing small electric charges. So when the electric charges are very small, minute, then you can use an electroscope to do that. You can use it made up of brass disc, insulating disc, brass rod, and the gold leaf. But importantly, we have the capacitor. The definition of a capacitor is that
It's
the
used for
capacity.
storing charges.
Yeah, it's used for storing charge, and it's simply made up of flat plates, conductors that are arranged in such a way that they possess equal and opposite charges, and they are separated by an insulator known as dielectric. So these are actually the components of a capacitor, and that makes capacitor the answer.
Okay, sir.
Are you clear on that?
Yes, sir.
Okay. So finally, for this evening,
What
we
did
look
you
at.
say?
I say finally for now.
Okay.
Yeah. We look at number 26. Which electric device does the diagram above illustrate? Is it AC generator, AC motor, DC generator, or DC motor? Okay, this is a typical diagram of an AC generator. So you can see down here, I also redrew the diagram and in full so that you can actually understand the various components in case if you're required to do such in theory physics. Okay, so this is the armature. This is the mechanical device for turning. These are the horse magnets, the north and south pole. This is the carbon brush, the slip ring. The difference between the AC generator and the DC generator is simply, instead of having the split ring, the slip ring as in the AC generator, in the DC you have what we call the split ring. Are you clear on that?
Yes, sir.
So once you have these two different things, is the slip ring, just like we have here. Or if you have something being divided at the middle, split ring, then you're talking about DC circuit. Okay, so we are going to be stopping here.
I said,
I can't hear you.
so what did you say?
I say we'll stop. We'll log out now. Then I'll solve out the rest. Then I'll see whether I will, if I'm able to finish in time, I'll send you a link. If not, we'll continue on Monday. By Monday, I should have sorted out the both this one and the remaining chemistry.
Okay, sir.
Yeah. So I hope you
So, sir,
enjoyed
should I
it.
still expect you by today?
I'm not promising, but I'll try my best and see.
Okay, sir.
So I want you now to work on 2020. Is that clear?
2020.
Physics and chemistry.
So, for what subject?
Okay, for physics, physics we've not done 2019, but so what you're going to do, work on
First question for 2020. They didn't give. Yes, we've not done 2019,
okay,
and I don't have 2020 for physics. They didn't give.
Okay, they didn't give.
The bookshop person said they did not able it.
Okay. So let's work with 20. Okay, don't worry. I will send you the one I want us to work on. Yeah, good evening. I'll send you the one I want us to work on WhatsApp. Okay. But make sure you're done with 2019 physics. Work on 2019 physics first. Then I will tell you the next one for chemistry and the next one for physics after that. Said what? Okay, thank you. See you when I see you. God bless you. So Chika, what took you so long to join?
Did you see was connecting? Good evening, sir.
Okay, so let's quickly start immediately. We are going to be doing chemistry, the remaining 2019 chemistry from tomorrow. So
Okay,
try as much as we can to do some physics. Then tomorrow we'll continue with the rest of the chemistry.
okay, sir.
Tell your uncle that I called him yesterday, but he didn't pick.
For
Tell your uncle that I called him yesterday.
hello. Okay.
So do we continue? Chika, can you hear me? Can you hear me, Chika?
So we can continue.
Okay, a simple barometer is constructed using a liquid Q.
Hello.
Can you hear me? Tika, can we continue?
Yes, sir, we can continue.
Okay, a simple barometer is constructed using a liquid Q1 of density 16.2 gram per cm cube. Calculate the least length of the tube to be used to measure pressure of 1.5 atmospheres. Given density of mercury is equal to 13.6 gram per cm cube, and that 1 atmosphere is equal to 76 cm cube of mercury. So the options are A, 1,358 millimeter, B, 957 millimeter, C, 760 millimeter, and D, 638 millimeter.
Hello.
Yes, can you hear me?
Yes, I can hear you.
Can you see my screen?
Yes, I'm seeing it.
You can see it very well, but
Yes, sir.
okay. So the answer is 957. Why? Because density is inversely proportional to the size increase. So if you take the density times the distance that can be measured, is the same as the density of mercury times the distance that can be measured by the mercury. So get that distance as 63.8. So if 63.8 is for 1 atmosphere, X will be for 1.5 atmosphere. So make S the subject, then you get 957 millimeter. If you check the past question, you see that they got it wrongly. So take note. Most of the things, some of the things, few of the things they have in past questions, they don't do it very well. To research before we come up with this.
Yes.
It's clever. Can I move on?
Yes, I'm writing this.
Okay, I'll leave you time
Hold
to
on.
quickly, be fast. Yeah, hold on.
So you can move on.
Okay. When you can see the question number 28 on your screen, let me know.
Okay. So it's 28 I'm seeing now.
Okay, showing already, okay? Can you see the sketch up there? A bar AB is balanced horizontally on 2 knife edges, as illustrated in the diagram above. Determine the weight of the bar.
I was 28 that I was showing before, not 27. I even thought it was 27.
Said what?
I said it was 28 that that was showing on the screen before.
Can you see 28 with a diagram on top now?
Yes, sir. I said before
Okay.
it was 28 that I was showing.
Okay. I didn't know. So let's continue.
A bar AB is balanced horizontally on two knife edges as illustrated in the diagram above. Determine the weight of the bar. Option A, 10.0 newtons, B, 20.0 newtons, C, 40.0 newtons, D, 50.0 newtons. So in order to understand this first, we had to redraw what is up there. The only thing here now, the second sketch, is that we now indicated where the weight is acting at the middle, and it's represented with F3. So F3 is equal to weight. So the weight is at F3, which is equal to W. At the middle of the forces, F1 and F2. And it is the weight that balances F1 and F2. So we have what we call the first and second conditions of equilibrium. What is that? Okay. The first
Please,
condition
you say
for
number 27 to me after this class.
Okay, you didn't finish writing it.
Yes, I didn't see number 27 on the screen. It was 28 I was copying.
Okay, you are copying 28 instead of 27.
Yes. It was not showing on the screen.
See, it's your duty to know what you're seeing on the screen and report to me so that I'll show the right thing, Abby.
Yes.
How can you be seeing another thing and I'm explaining another thing and you did not call my attention since and I finished and went to another one and you're calling my attention to what I passed? Chika,
Sir?
let's start afresh again. Make sure you're telling me what you're saying so that I don't have to come back again. Can you see 27 on your screen now?
Okay.
Can you see 27 on your screen now?
Yes, I can see it now.
A simple barometer is constructed using a liquid Q1 of density 16.2 gram per cm cube. Calculate the least length of the tube to be used to measure pressure at 1.5 atmospheres. Density of mercury is equal to 13.6 gram per cm cube. 1 atmosphere is equal to 76.0 cm cube of mercury. So the options are A, 1,358 millimeters, B, 957 millimeters, C, 760 millimeters, D, 638 millimeters. So density is inversely proportional to the size increase. And because of that, we set out this equation like this. So for that Q that you don't know, 16.2 cm can be 16 point, that's Q1 you don't know that has the density of 16.2.
Hello.
It can measure X, 16.6, measure what corresponds to 1.5 atmospheres. So make S the subject of the formula, and you get 957 millimeter mercury. That is the answer. And like I was noting the other time, I told you that when you check the past question, the answer should be either D or something. Or take note, that should be what the answer should be. So let me know when you're done copying it so that I'll move to the next screen.
Okay.
Are you done?
So you can move to the next one.
Okay.
Doesn't work when it's just. Doesn't work when it's just.
Please, once you can see 28, let me know.
I can see it, sir.
Can you see 28?
Yes, I can see it.
Okay. A bar AB is balanced horizontally on two knife edges as illustrated in the diagram above. Determine the weight of the bar. A 10.0 Newton, B 20.0 Newton, C 40.0 Newton, D 50.0 Newton. So solution, I simply redrew the diagram that we have here, but because we are told to calculate the weight, so I indicated the weight. The weight is supposed to, because these two forces are equal, the weight should be at the center and it should be towards the ground. So the weight is F3 and it's at the middle. But before we can solve this, we need to know the two conditions necessary for equilibrium to occur. Or actually one of the conditions to be able to give us the right answer. So for equilibrium to occur, the total upward force must be equal to the total downward force. So these are the upward force, the F1 and F2. So the total of it must be equal to the down. That's why we have F1 plus F2 must be equal to F3. So 20 plus 20 equal to F3, which is simply equal to 40. That's the first condition of equilibrium. Second condition is that the total anti-clockwise moment must be equal to the total clockwise moment. If there was a case where we are told to calculate the distance between C and B, then we would have used this second condition for equilibrium to do the calculation. But I just stated it so that you know these are the two conditions necessary for equilibrium to occur. In case if you have similar problems,
So, sir, anytime they say we should find weight, it's always in the middle.
it's only the what?
I said anytime they say we should find weight, it is always in the middle.
No, it's
What
not
we're
always.
looking for is in the middle.
This one is only in the middle because the two forces are already balancing. Is that clear? In other cases, they will give you the distances. So you have to use this second condition of equilibrium to either calculate the position where the weight will be.
Okay, sir.
Okay, but take note of the two conditions necessary for equilibrium to happen. Can you state those two conditions now?
Yes.
Okay, so let's move forward. If you can see my screen, let me know. 29.
I can see it, sir.
You can, okay. To obtain a virtual, erect, and magnified image from a thin converging lens, an object must be placed A, between the focus and the lens. In this case, the lens can also be called the pole. B, at the focus, C, at the focus. C, between the focus and twice the focal length. D, between twice the focal length. Between twice the focal length. I wouldn't know whether anything is here. Okay. So the answer is A, between the focus and the lens, because for converging lens, depending on where you place the object, that determines whether the image is going to be real, virtual, inverted, diminished, or magnified. So we're going to draw the possible cases. So this is the first case. And in this case, the object is placed after C. So what kind of image image does an object that is placed is between F and C. So you can see of curvature. F is the principal focus. Image is real. It's inverted. You can see it's inverted. It's diminished. It's not magnified. It's reducing. So these are the properties of object that is placed after center of curvature. So you can see the image. It's inverted, diminished, real, and between F and C. So another instance is where you place the object at C, at the center of curvature. You can see the object here. You can see the image. Here, the image is also at C. The image is real. It is also inverted, and it's at the same size of the object. You can see the size of the image is just the same as the object. So that's another case. Now, another case is when you place the object, this is the object, between center of curvature and focus, between C and F. So in that case, it will produce this image. And this image is beyond C. It is real, it is inverted, and you can see it is magnified. It's far bigger than the object. So this is another case where you place the object at principal focus, F. So in this case, the image is at infinity. You can see, you cannot even locate the image here. The image is real, the image is inverted, and the image is magnified. Then lastly, you can have the object placed between the pole or the lens focus. In that case, this is the image. The image is behind the mirror. It is virtual, erect, and magnified. So from the illustration I've given you now, which of them do you think answers the question? Check out.
The last one.
The last one, good. Because they are looking for the one that will produce an image that is virtual, erect, and magnified. And you can see the last one produces an image that is virtual, erect, and magnified. But where is the position of the object? It is between the pole and focus. And that makes A the answer, between the focus and the lens. So another thing to take note of here is that for a concave...
If you want to.
You said what?
I said if you want to know all this, how will you know all these diagrams?
Yeah, you can only know them by practicing them.
Like how did you know the converging lens was meant to be? Okay.
You can only know them by practicing them. Is that clear?
Okay, sir.
Yeah, that's why I took our time to draw all of them, so that at your own time you can practice them. Is that clear?
Yes, sir.
So these are the different type of images that a concave mirror can produce. For a convex mirror, the image is always smaller, erect, and virtual. For a convex mirror, so the image is the same thing no matter the position of the object. But for a concave mirror, you need to have, it has different positions at different positions of the object. So another thing you need to know that a concave mirror can be used as a shelving mirror.
Okay.
So that's the application. Okay. So let's move forward. We just finished 29, but
Yes, sir.
so let's look at 30. Please, once you can see 30, you let me know.
I can see it now.
Okay. The diagram above represents a transverse traveling wave Which 2 points are 180 out of phase? Okay, you have option A and E, option B and D, option C and F, option D and F. So option A is A and E. A is here, E is here. So they actually are on the same phase. B and D, this is B, this is D. So B is 90 out of D and another 90. So 90 plus 90, you have 180 out of D. That makes it the answer. Then option C and F, this is C, this is F. So C is just 90 out from F. Option D and H. This is D, this is H. They are on the
I
same
don't
phase.
really understand.
Okay, so watch again as I'm demonstrating. Can you see D? Can you see D? Can you see D?
Yes, I can see.
Can you see H?
Yes, I can see.
Can you note the places where they are, both of them are formed? They are, both of them are on the trough.
Yes, I can see.
So they are on the same phase. Can you see A and E?
Yes, I can see.
Good. They are also on similar points on this, just like these ones are on similar points.
So why is A and
Also,
E not the answer?
huh?
Sir, why is A and E not the answer?
That's what I'm explaining to you now. You can see D and E, they are on similar position, just like A and E. If you check the past question, they gave A and E as the answer, but they are wrong. Can you see the positions of D and E? Can you relate them to A and E?
Yes, I can see it.
Okay. So if D and E, if A and E is the answer, D and H should also be the answer. Because you can see that they are on similar places on the sketch. Hmm?
Yes.
Okay. So the other ones that are not the same now, you have B and D. This is where B is, and this is where D is. So you have okay, we have C and F too. This is C, this is F. So this cannot be because they are at are you looking at this sketch? Can you look at this sketch? From here now to here
Yes,
is 90. From here to here is 90. From here to here is another 90. So a complete half of the circle is 180. Another complete half is 180, making it 360, which is the complete. So if you have from here to here alone is 90, from here to here is 90. So if you look at B and D, from here to here, 90 and another 90. So making it 180 out. And you can definitely see that both of them are not on the same point on the wavefront.
Okay, sir.
Did you get that now?
Yes, sir. Hello.
Did you get what I just said?
Yes, I got it.
Okay, so let's move forward. When you're seeing question number 31, let me know.
Okay. I can see it now.
Okay, two objects P and Q of masses 100 kg and 20 kg respectively are 1.2 meter apart on a horizontal surface. Calculate the net gravitational force acting on Q. G is equal to 6.67 times 10 to the power minus 11 Newton meter squared per kg squared. Option A, 1.11 times 10 to the power minus 7 newtons towards P. Option B, 1.11 times 10 to the power minus 7 newtons towards Q. Option C, 9.26 times 10 to the power minus 8 newtons towards P. And option D, 9.26 times 10 to the power 8 newtons towards Q. Now, solution. Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force that is proportional to their masses and inversely proportional to the square root of the distance between them. And that force must act along the line joining the centers of the particles. So this is the statement of the Newton's law. F is proportional to the product of their masses all over the distance between them squared. Then changing the constant of changing this proportionality sign with a constant G, you now have this. So if you substitute these values, you have for G, it is given 6.67 times 10 to the power minus 11. The two masses are 120 all over 1.2 squared. So if you do this calculation, you get 9.26 times 10 to the power minus 8. And it must be towards P, not towards Q, because Q must be attracted towards P in order for it to obey the Newton's law that says that two of them must be attracting each other. Do you understand that?
Well, I don't understand the Q must be attracted towards P. Must be attracted towards P. So.
Must be attracted towards
P. I don't understand that statement.
Okay. You're looking at Q. Can you see this Q that you're looking at? Can you see Q here?
Yes.
So they told you to calculate the net force acting on Q.
Okay.
So Newton's law of gravity states that they must attract each other. Every other body must be attracting the other one. So the force acting on Q must be in such a way that it will be towards P, because you're talking about P and Q. If you're talking about the force on P, it should be towards Q. But if you're talking about the force on Q, it should be towards P, because two of them have to be attracting each other. So if you have a force acting on this Q, it has to be directed towards the other one. If you have one acting on this one, it will be directed towards this other one.
Okay, sir.
Is that clear to you?
Yes, sir.
Okay, so let's move on. Please, if you can see question 32, let me know.
I can see it, sir.
Okay, the primary of a transformer has 100 turns and its secondary has 200 turns. If the voltage at the primary is 100 volt V, determine the voltage at the secondary. Option A, 50 volts, B, 100 volts, C, 200 volts, D, 400 volts. Solution. Mutual inductance is the flow of induced current or voltage in a coil due to the alternating or varying current in the coil, neighboring coil. So if you're having a step-up transformer, you're going to have lesser coil on the primary and have more on the secondary. Whereas if you're having a step-down transformer, you're going to be having more coils on the primary, and you'll be having less on the secondary. Because the more the coil, the more the EMF. And that's what we have here. The more the coil, the more the EMF. The more the coil, here the coil is represented by N, which is the number of turns. And this is the EMF. And it's inversely proportional to the current. So that's why you have to transpose the current here. You have to have the primary on top and the secondary down. But for the
two types of coil are their names step up and step down.
EMF, which is also the... Come again, I cannot hear you.
Like, what is step up and step down?
Okay, I just explained it now. Once you look at the transformer, this side is known as the primary coil, and this side is known as secondary coil. This side primary, this side is secondary. Once the number of coils in the primary is less than that in the secondary, we call it step up. Because you can see EMF is being stepped up from here to here. Here, there's lesser number of coils. Here, there is more. But you can see it's moving from more to less here. We call it step down. If it's moving from less to more, call it step up. So this is a step up transformer. This is a step down transformer. This side is the primary coil. This side is the secondary. The same thing as this other one.
So you can move on, I understand now.
You understand now, good. So using that, you can state this formula, ES over E equal to NS over NP. So ES is what you're looking for. EP is 100 equal to number of turns for secondary is 200. Number of turns for primary is 100. Make S the subject, you have 200 V. And that's why 200 is the answer.
Okay, sir. I'm just that.
Can move on, ba?
Yeah. So
Once you can
move
see 33, let me know.
I can see.
Okay. In the diagram illustrated, a block of mass M is at rest on a plane inclined at an angle theta to the horizontal. As theta increases, the velocity ratio of the plane does what? A increases, B decreases, C remains the same, D decreases, and letter increases. Please, this is a mistake, and letter increases. Okay, solution. For the mechanical advantage and velocity ratio for an inclined plane, if the frictional force is absent, then the mechanical advantage is equal to mechanical ratio, and both of them are equal to 1 over sine, the angle of inclination, 1 over sine. But if there is actually friction, then the MA is actually less than the VR.
Well, sir, they didn't mention the mechanical advantage here.
Huh?
They didn't mention the mechanical advantage here.
No, I didn't say they mentioned it. I'm just giving you a concept behind the solving.
Okay.
So in case if they mention it tomorrow, so that you know that it's also equal to 1 over sine theta if friction is absent. Is that clear?
Yes, sir.
Okay. So velocity ratio is equal to 1 over sine theta. Now, they are asking you, if you increase theta, what will happen to the velocity ratio? Is that the question?
Yes.
Okay.
Now, yes.
Good. So let's say the angle is increased from 40 to 90. Let's see what will happen. So using this formula, VR is equal to 1 over sine 45. And sine 45 is 0.707. So if you solve this out, it will give you this. or if it is 90, sin 90 is 1, 1 over 1 is 1. So you can see that when you increase the theta from 45 to 90, the VR reduces from 1.44 to 1. That means it's actually increasing. As you're increasing the theta, the VR is decreasing. That makes option B the answer, decreases. Suleiman, please correct more for me. Come on, hold on.
I did I times it by 2.
You said?
Like, how did you know it will be sin 90? Or anytime you just
How do
want
I
to
know it's
do
what?
sin 45, it is always going to be
No,
sin
no, no.
90.
I just assumed. I just assumed any. You can actually assume any theta you want, but just make sure that the first one, second one is bigger than the first one, because they want you to check once you are increasing the angle. You understand? Anything you use, it will give you. But why would you choose 45 and 90? Because with 45 and 90, even without calculator, you can know what their signs are.
Yeah.
It's generally known that sin 90 is 1 and sin 45 is 0.707. So you use these thetas that you can easily, without calculator, you can solve out with. Come here, Aliu. Sit down there when he comes.
Okay, so
Is that clear?
yes.
Take vitamin. Vitamin. Can I move forward?
Yes, I can move forward.
What number did we just do?
33, why number 34 now?
Okay.
I can see it.
You can see it clearly.
Yes.
When the speed of a car is halved, its kinetic energy is A, doubled, B, quartered, C, halved, D, quadrupled. So in order for you to get this, you need to know the representation for both kinetic energy and the relationship between kinetic energy and speed. In order for you to know what happens to the kinetic energy when the speed is halved. So the relationship between kinetic energy and speed is that Ke is simply equal to half mv squared. This place V is showing us the speed. So we're going to assume values for V. I will try to have it. So when we have it, so we have it and we see the relationship. So we have K equal to half mv squared. So let's say that V is equal to 1. And let's
Can you zoom in a little?
say,
Can you zoom in?
okay. Aliu, he's talking to somebody and you are listening and you're keeping quiet.
Yeah, I can see it.
Talking to who? Are you seeing it well now?
Yes, I can see it now.
Why did you ask you whether you're working here? You say you're working here.
Sir, can you hear me? I said I can see it now.
But did you ask you whether you're working here? You say you're working here. Why?
Hello.
Make sure you're taking care of what is happening there.
Sir, can you hear me?
Yes, I can hear you. Can you see my screen?
Yes, I can see it.
Okay. Do you have any question?
No.
Can you see my screen?
I can see it.
Okay. When the speed of a car is halved, its kinetic energy is A, doubled, B, quartered, C, halved, D, quadrupled. So we have solution KE, which is the kinetic energy. The relationship between kinetic energy and speed is that kinetic energy is equal to half mv squared. So let's assume, because what we are changing is the speed, let's assume that the mass is always 1. So we take for speed of 1, then we take for speed of 2, and possibly take for speed of 4. Since 1 is half of 2 and 2 is half of 4. Yes, I'm listening to you.
I said they said the speed is half. Why didn't we put V as half?
That's what I'm trying to explain to you.
Okay.
Are you listening?
Yes, I'm listening.
Good. That's why we tested for V of 4, 2, and 1.
Let's stop that now.
So if you say that V is half, you can also assume that it has moved. Is 2 the half of 4, Chika?
Sir?
Is 2 the half of 4?
Yes.
Is 1 the half of 2?
Yes. No, it is.
Good. Huh?
I said yes, it is.
Okay. So if you have the speed of the car from 4 to 2, from this our solving, you see that the KE is going from 8 to 2. If you also have the speed of light from speed of the car from 2 to 1, you will see that the KE is moving from 2 to 1. So if you assume the speed to be 1, what is the KE? Simply substitute. You're assuming mass to always be equal to 1. So if you substitute, you get half. If you assume the speed to be 2, the mass is 1, substitute, you get KE to be 2. If you assume the speed to be 4, substitute, you get your KE to be 8. So you see, as we are moving from, as we are having, you go from 4 to 2. The KE went from 8 to what? 2. So what's the relationship between 8 and 2? Or between 2 and 1? I mean, between 2 and half. What's the relationship? It's simply telling us that as we are moving the speed from 4 to 2, we are having it. The K is moving from 8 to 2. You can see this speed of 4. The speed is 4 here. The speed is 2 here. But here the KE is 8. Here the KE is what? 2. And you know that 1/4 of 8 is 2. So it has actually been quartered, whereas this one has been halved. So as you're halving the speed, the KE is being quartered. So if you forget about moving from 4 to 2 and you consider moving from 2 to 1, the same thing happens there. From 2 to 1, you can see that the KE is moving from 2 to half. So what's the relationship between 2 and half? 1/4 of 2 also gives you half. So the answer is quarter.
Okay, sir.
Is it clear?
Yes, sir.
Did you see the way we approached it? You have to take note of the approach. That's what matters. We assume the mass to be 1. This is the formula that you're going to use. But you assume M to be 1 in all the cases. Then you just vary the P by trying to have it using any value. It mustn't be 2 and 4 and all this. It can also actually be any halving value. You can use 3 and 6 because you know that 3 is the half of 6. If you still do it, you will see that it's being quartered also.
Okay, sir.
Do we continue?
Okay, sir.
Okay.
Yes, sir.
Please, once you can see 35, let me know.
I can see it, sir.
Okay. A wire of length 400 cm is stretched between 2 fixed points. When plugged, its fundamental frequency is 150 Hz. Calculate the speed of the wave produced. Option A, 250 meters per second. B, 625 meters per second. C, 1,200 meters per second. D, 1,500 meters per second. Okay, solution, you can see the sketch here. So these are the 2 points, and this length is 400. Now, this length is actually equal to half the wavelength. So this length is equal to half the wavelength. But we know the formula for frequency is that frequency is equal to speed over wavelength. But we are not giving wavelength. But we know that this length is equal to half the wavelength. So make wavelength the subject, you have 2L. So put it back into this equation. F is equal to V over 2L. So make V the subject, V is equal to F2L. 150 times 2 times 4, making it 120 meters per second. If you're done writing, let me move on if you understand it.
Sorry, how they say okay between 2 fixed points?
You say?
I was asking how did we know that it will be V over 2L? Because there's also another one for V over L.
V over what?
That did you hear me?
Also another one for what?
Another formula that is F is equal to V over
No,
L.
there's no F equal to V over L. It's only F equal to V over this sign, wavelength. This is the formula, F equal to V over wavelength.
No, like the other formula that V is equals to 3 over L over 5L.
Yeah,
No, those ones.
depending on if this you see this one is just starting from year to year. In some cases, it will go like this and come up like this and go like this and come up like this. So depending on the number of partitions that you have.
So they didn't give us the diagram in the question. No.
Yeah. This diagram is just explaining what you read. You see, a wire of length 400. Can you see that? A wire of length 400. This is the length of the wire. From here to here is 400. Is stretched between two fixed points. So it's just between these two fixed points. They didn't tell you that it breathes somewhere in the middle. Now, when it is plugged, this is the wire. When you plug it, it will start vibrating up and down. Do you understand? So the diagram you draw is based on the question that you are giving. The diagram I just gave you now is from what I read from the question.
Okay, sir.
Yeah. Okay.
We can move on.
Okay. Once you can see my screen, let me know.
I can see it, sir.
Okay, 36. The diagram above illustrates a waveform. Determine the number of wavelengths in it. Option A, 4, B, 3.5, 2, 2.5, D, 2. Solution, one complete circle is one wavelength. So if you consider this from here and here, this is 1, 2. So you can see that here from here and here completes one circle. Then this B from here and here completes another circle. Then this one is not even up to half a circle. So, but you have here, then if you combine it with what is here, this 1/4 plus this 1/4 will give you half. So you actually have how many? 1 plus 2 plus half. So it will give you 2.5. So one complete circle equal to one length, one wavelength.
So I said, sorry, please, what is the difference between the quarter and the half? This quarter looks like the half.
What's the difference between what?
On the wavelength, this quarter looks like the half.
Okay, actually, this is quarter. This one is quarter. Half is one full like this. Can you see this point? This is half. And this is another half.
Okay, yes.
It must curve fully like this to be half. Then if you curve again, it becomes one full wavelength, which is a complete circle. This one also, half of B, half another one. That's another one complete circle. But you have this here is quarter because it did not reach half. So you have this quarter plus this quarter, making it half. So we have 1, 2.5. Abi?
Okay, so I understand now.
Okay. So let's move on. Can you see 37?
Yes, I can see it.
Okay. A resistor with a fixed resistance value is called A resistance box, B standard resistor, C shunt, D multiplier. So what do you call a resistor with fixed resistance value? Solution, a standard resistor or standard resistors are resistors which have fixed values. Example, they can have values like 1 ohm, 2 ohm, 5 ohms. And this is how you represent a standard resistor. Whereas a variable resistor can have varied resistance. This is how you represent a varied resistor. So with that, you can see that the answer is B, standard resistor. So these other definitions are just what you need to know in this very topic. Okay, so we are signing off now. We'll be logging out. If I'm able to log in again, then we'll finish up. But if I'm not, tomorrow we'll be looking at chemistry.
Okay. So let me finish right.
Huh?
So I'm jotting this down.
You said?
So that diagram that you put for variable resistor, is that not the one for rail start? It looks like
What?
it's for rail start. The diagram for variable resistor, is it for rail start?
Yeah. Okay, you can actually use real stars to supply varying potential difference. But what I gave you is actually for
So
variable
they have
resistor.
the same diagram. So they have the same diagram.
I'm not sure about the one for the real start, unless if that's what you've seen as the diagram for real start. Are you clear on that?
Yes, sir.
Okay. So see you when I see you. Tell your uncle to call me. I called him yesterday and he didn't pick. Very important.
Okay, so I'll tell him.
Please help me unlock that. So I want to stay outside. You can stay outside, but lock it. I want to be locked inside. If you want to stretch your legs outside, you can do that. If you want to stretch your legs outside, you can. But I want it to be locked. The red key. Yeah, the inside one. Just the inside one. Leave the outside. Yeah, Chika, are you there now?
Yes, sir.
Okay, please confirm if you can see question number
Okay.
38 on this. Can you see 38?
Yes, I can see it.
Okay, which of the following statements is not an advantage of an alkaline accumulator? So there are different cells that you can use to supply energy, EMF, or current to your circuit. So you can use primary cells or secondary cells. So amongst the secondary cells, you have your alkaline accumulator, your acid accumulator as well. Okay, so it's asking, which of the following statements is not an advantage of the alkaline accumulator? A, the electrolyte does not need attention. B, it can be recharged. C, it has low internal resistance. D, it has a much longer life than lead acid accumulator. Okay. Now, to put this in perspective, we need to understand what the alkaline accumulator is. So the alkaline accumulator, also known as the nickel ion accumulator. So that's the other name for the alkaline accumulator. It has a positive nickel plate and a negative ion plate with a solution of potassium hydroxide. That's why it is called alkaline accumulator, because it has potassium hydroxide is an alkaline. So it has it
So,
as the electrolyte.
well, okay, I'm seeing it now.
Okay, you're seeing it now. Okay, good.
Yes.
Now, like all secondary cells, how do you know a secondary cell? If it can be recharged, the secondary cell, and that's an advantage. Simple cells or primary cells, they are not recharged. Once they are used up, they are gone. Now, they have low internal resistance, very, very important. And also, nickel accumulator or nickel ion accumulator has a longer lifespan than the lead acid accumulator, which is also a secondary cell. So you can see that 3 of what is up there is already listed. It can be recharged, it has low internal resistance, and it has longer lifespan. So with that, you can easily pick out the answer. What do you think is the answer with what I just stated so far? Which one?
Much longer life than the lead accumulator, lead acid accumulator.
No, that's an advantage. It's asking you for the one that is, if something has longer lifespan, that means it's durable, it's good for work.
Yeah, the electrolyte does not need attention, so.
Yeah, that's what it is. Okay. So let's move forward. Let's move forward. Okay, let me know when you can see my screen. With number 39.
I can see.
Okay. So make sure you tell your uncle that we covered a lot today for the time we missed yesterday, okay?
Okay, sir.
Yeah, he was trying to chat me up that we didn't have our class yesterday. Okay, the diagram above illustrates the wire connection to a 3-pin plug. The wire connection to a 3-pin plug. Now the wires P, Q, and R respectively are what and what? Is it A, live, neutral, and earth? B, neutral, earth, and live? C, earth, life, and earth? D, earth, neutral, and live. Okay. So this is what is drawn. This is what I could sketch from what was given on the Q&A. But this is the actual diagram of a 3-pin plug. So you can see that the one by the left is always the neutral. The one at the middle is the earth. Whereas the one that is connected to the fuse is the live wire. So that means P is the neutral, Q is the earth, whereas R, connected close to the fuse, is the live wire. So with that, which option do you think is the answer?
B.
B, okay. So that is the answer already, but to put this more into perspective, so this this is your 3-pin that you normally plug in. Most devices, they are connected to this 3-pin plug. You know what a plug is? Chika, do you know what a plug is?
Yes, sir.
That outlet that lets you plug something to the wall or to the switch so that you can use it. So most of them are having 3 pins. So that's why they call them 3-pin plug. The ones having only 2 pins, they are known as 2-pin plugs. Okay. So a 3-pin plug consists of 3 pins. The 3-pin plugs are designed so that electricity can be supplied to electrical appliances safely. So they are connected in such a way that they will supply electricity safely. So how do they connect? How do they supply electricity safely because of the earth and other things? For the 2 pins, they are also known as class 2 electronics. 3 pins are known as class 3. 2 pins are pin. You see that they are mostly having only 2 pins. Why? Because they are not having the earth. Because the voltages going into them are very small. That's why they can manage just the 2, the live and the neutral. Okay. So the color of the live wire is always brown. That of the neutral is always blue, whereas that of the earth is green and yellow stripe. Okay. So the live wire is held at a voltage of 230, provides the current. The neutral simply helps to complete the circuit, whereas the earth is for safety purpose. Okay. So is it clear? Jika, is it clear? Are you still there? Please let me know when you can see question 40 on your screen. Are you there now? Can we continue? Tika, can we continue?
Hello.
Yeah, can we continue?
Yes, sir, you can continue.
Okay, which of the following statements about parallel plate capacitors is or are correct? A, capacitance of the capacitor is inversely proportional to the distance between the plates. 2, capacitors can filter AC signals from DC. 3, capacitors can store charges. Okay, the options. A capacitor is actually a device for storing electric charges. The capacitance increases with area between the plates but decreases with increasing distance between the plates, and also increases with the dielectric constant. So this is a simple diagram of a capacitor showing the plates. These are the plates, the Qs are the plates, the positive and the negative metal plates. They'll have the insulator or the dielectric plate in between. So the more this distance, the lesser the capacitance. Okay. So what and what can you use the capacitor to do? You can use them to tune your radio circuit. You can also use it in the ignition system of motor vehicles. You can also use it to eliminate sparks in circuits that have inductance. Okay, so from the foregoing, yeah, so Chika,
Sir.
Chika, are you there? Please, you have to resend me this very question because the options there, they don't really seem to be consistent with what is supposed to be.
Yes, sir, it's meant to be I
Okay.
and I.
Yeah, something like that, but I'm not understanding what they have there, okay? So this is the symbol of a capacitor, but take note of these facts that I wrote here. I don't know, maybe should I send you this soft copy? Do you need it, or are you writing down immediately?
So I'm writing it down.
Okay, right. So get all those. Okay, so let's move forward. So I think I left one unsolved. I think 41, which I'll solve later and give you. So if you see 42, let me know on your screen.
So I can see. So I just send the question.
Okay, I'll check it. Which of the following statements about magnetic lines of force is not correct? A, pass through even non-magnetic metals. B, run from the North Pole to the South Pole. C, are in a state of tension and tend to be shortened. D, intersect one another. So solution, the region or space around the magnet in which the influence of the magnet can be felt is known as the magnetic field. The effect of the lines of force or patterns or nature of the magnetic field around a bar magnet can either be studied using ion filings or magnetic compass needle. And when you do this study, you find out that the magnetic fields run from the North Pole to the South Pole. Very important. Number two, the lines of force do not cross each other. They never intersect. They never intersect. And number three, the magnetic lines of force of the magnet is defined as the line along which the free North Pole would tend to move if placed in the field, or a line such that the tangent to it at any point gives the direction of the field at that point. So with that, you see that the statement indeed that says that it intersects one another is wrong, because the lines of force do not cross each other. So that makes option B the answer. Are you clear on that?
Yes, sir.
Okay. Please let me know when you can see 43. Yeah, can you see 43? Can you see 43?
Yes, I can see it. I can see it.
Okay. In which of the following activities is an induction coil not useful? A. Investigation of high voltages. B. Study of electric discharge. C. Operation of X-ray tube. D. AC power transmission. The induction coils are used to provide high voltage for electrical discharges in gas at low pressure, and as such were instrumental in the discovery of cathode rays and X-rays in the early 20th century. Now, an induction coil is an electrical device for producing an intermittent source of high voltage. And it's actually done by electromagnetic induction from low voltage DC source of a battery. So the answer should be AC power transmission, because induction coil is commonly used in motor car ignition and in operation of X-ray tube. You can already see X-ray tube here. You can also see high voltage here. You can also see electric discharge. Okay. Let me know if you can see question number 44.
I can see it, sir.
Okay. In a series RLC circuit, R is equal to 10 ohms, XC this is the capacity, XC is 4 ohms and XL is 9 ohms. So what is the impedance? Is it A 4.1 ohm, B 5.0 ohm, C 10.8 ohm, or 11.2 ohm? Impedance is the overall opposition of a mixed circuit containing a resistor, an inductor, and or a capacitor. And it's measured in ohms. So we have XC to be equal to this and XL to be equal to this. But if you're calculating the overall impedance, it's going to be R squared plus the difference from what you get from the inductance and that of resistance from the inductor and that from the capacitor squared. So having that, this is what you have, but this they are already given to you. So you simply get down to this last formula because this from here is equal to this and this is equal to this. So you're giving this as 9 and you're giving this as 4. So you simply say 9 minus 4, which is 5 squared, 25, 10 squared is 100. 100 plus 25, you have solved 125, which gives you approximately 11.2, making that the answer to the problem.
So please scroll down small.
Okay, this is down.
Okay, so you can continue.
Okay. So let me know when you can see
I can see it.
45. A student uses 2 compass needles to investigate the magnetic field around a Bohr magnet. Which of the following diagrams show the correct direction of the needle? So what you're going to be looking for is locate where the north is and make sure the arrow is facing from the north to the south because that's how it moves. That's how the magnetic field moves from north. You see this north moving to south. It cannot be from south moving out and into north. So make sure that's what you should be looking for. Okay. So you have magnetic field is investigated using ion filings and compass needle. So the first question we had was on compass needle. This one is on ion filings. So you can see the direction of these arrows. They are moving from north into the south. Moving from north into the south. So you can see that in B, option B, is the north. You can see the arrow is moving out of the north into the south. You can see this is into the south. So you have to check the direction of the arrow and make sure it is from north to south. And that makes option B the right answer to this. Can we move on? Are you there?
Yes, I'm here.
Okay, let's look at question number 46. Which of the following particles may be emitted in a process of natural radioactivity? Is it A, alpha and beta particles, B, alpha and X-rays, B, C, beta particles and X-rays, D, gamma rays and X-rays? Okay.
Alpha and beta.
Alpha and beta, okay, that's true.
We did this one too.
Yes, natural emission. Radioactivity is the spontaneous decay or disintegration of nucleus of atoms of an element during which it emits alpha, beta, and gamma ray, or a combination of any or all of the three, and energy is heat as well. Okay, so you can see alpha and beta particle covers what we want. Okay, let's move on to question number 47. In which of the following situations is photoelectric effect employed? Where do we use photoelectric effect? Is it in 1, automatic device for switching on lights at dusk? B, automatic doors in departmental stores? 3, automatic device for switching on air conditioners? And 4, automatic voltage stabilizers? We have A 1, 2, and 4, B 1, 3, and 4, C 3 and 4, D 1 and 2 only. I will check out the description. When light falls on metal surfaces, electrons are emitted in what is called photoelectric effect. So photoelectric effect simply means the emission of electrons due to light. That's why we have photo. Photo means light. Electric, as you all know, relates to electrons. So when electrons are emitted due to light, we have what we call photoelectric effect. And that phenomenon is utilized in photocells. That is the principle on which photocells work. So where and where can we have photocells employed? Photocells can be used in burglars' alarm, can be used in television cameras, can be used in automatic doors like departmental doors in the options. Can also be used in automatic switching of light, street lighting, and also in automatic digital counters. So those are where you can employ photoelectric effect. So with that, you can see the option D captures 1 and 2, which are clearly where photocells that employs photoelectricity can be used.
So you know we've done from 48 to 50 before.
Okay?
We've done from 48 to 50.
Okay, I've already done 48 to 50 with you, or have you? Is that what you're saying? Hello, Chika. Chika, are you there? So you said we've done this one already. That's what you're saying. Which of the following radiation has the longest wavelength? I would say it's radio wave, isn't it? Because radio wave has in the dimension of 10 to the power 4. The shortest is that's of wavelength is gamma ray, but gamma ray has the largest frequency. We've also done 49, which is in which of the following fields is radioisotope not useful? Radioisotopes, they are used for medicine, agriculture, but not in weather forecast. They are also used in oil exploration, so weather forecast is the answer. Then finally 50, a nuclide is represented by this. Determine the neutron-proton ratio, okay? So this is the atomic mass. Use it minus this one to get the neutron. Then find the least ratio. Okay.
So we'll choose
that,
41 now.
huh?
Number 40 and 41. 40 and 41.
40 and 41. Okay. I'll work on those two and I'll get back to you.
Okay, sir.
So while I do that, I want you to let's work on 2020. Okay. We need to work on 2029 for physics.
So
Then 20. Yeah, I'm listening to you.
So I didn't hear the year.
No, I didn't.
So what year did you say?
Okay. I'm saying let's work on 2020. That's 2020 for chemistry, since we are done with 2018 and 2019. For chemistry, 2020.
Okay,
then
sir.
For physics, we are working on 2019 of physics.
Yes, sir.
I hope that's cool.
Yes.
Okay, so by then we must have been done with 3 years for chemistry and 2 years for physics. Then we'll keep going. We are very close. Okay.
Okay, sir. I'll send the question for 2020 chemistry.
Yeah, please do.
Thank you,
Okay,
sir.
so with that, we'll come to the end of today. See you when I see you. God bless you.
Okay, so I'll be waiting number 40 and 41.
Yeah, please, I'll do that. Possibly tomorrow, I should be able to send them across to you.
Okay, sir. Thank you.
You have to snap them since they are the only two. Let it be very clear, okay? So that I don't have problems.
So we can only two.
Huh?
I should snap 2019 for physics.
No, I mean the problem, the one that we did not solve, those two, snap them boldly. Then you also snap the
I snapped it and sent it.
yeah. Then you also snap the 2020 that we want to do for chemistry, as well as the what's it called, 2019 for physics.
Okay,
Yeah,
sir.
thank you.